Alright, so this is going to be a little like review series. This is going to be 8 parts. This is part 1. Alright, and I'll add some timestamps just so you can go back and go to whichever section you want to go to. We'll be covering a little bit of an introduction just on statistics and then actually get into the important content you should know. But anyways, let's just get started. Alright. So basic understanding of statistics. So essentially, right, statistics is basically just testing the chance or the statistical probability of something, right? Obviously. So an example, is there a statistical difference between A and A2, right? Alright, so generally in statistics, and especially in the units we're doing, we're going to be using a sample size to infer results of the population. In some questions, there will be just sample sizes, so no population, but at least for part 1, you're going to be comparing sample sizes to population, right? So an example again, do elementary school students in Alberta prefer math more than English? So how would you go about, finding the answer to this question? One, you could ask every single elementary school student in Alberta, ask if they prefer math more than English. Or option 2, you can ask a random sample of elementary school students in Alberta. So, I don't know about you, but obviously, probably choose number 2, right? It's a lot easier. And generally, as long as you get a decent enough sample size, then you probably will get somewhat accurate results, right? Now, a big important thing, though, with your sample sizes is that they obviously have to be random, right? And the sample sizes generally have to be somewhat large. Generally, obviously a bit over 25, but we'll get into that, right? So another thing you need to know, null and alternative hypothesis. So it's basically, the two options you could choose from in a question. It's either not yes or no, but it's more, binary. It's either this or this. So again, another example, we'll use the same as before. Do elementary school students in Alberta prefer math more than English? All right, so what would the alternative hypothesis be? Well, in this question, it'll be P is greater than 0.5. This question is pretty vague, and obviously when you're doing questions, there'll be more information, but just the important things about it is that it's asking, do the elementary school students prefer math more than English? All right, so the key thing is that they use the word prefer, right? Meaning, do they, like math more than English? And on top of that, there's no numbers, say like, it's not asking what's the mean amount of students that prefer math. It's just asking, do they prefer? So in this case, you would use P, and it'd be greater than 0.5, right? Because as long as the students, over 50% of the students prefer math, then you could statistically say, students, elementary school students in Alberta prefer math over English, right? And so the null hypothesis is obviously going to be the opposite of that. So it's going to be P is less than or equal to 0.5, right? So basically, the alternative and null hypothesis, or hypothesi, I don't know how you say it, they're basically opposites, all right? So just another example, instead of using P, we'll be using means. So last year, the mean grade for Stat 2 and 7 was 72.3 out of 100. Did students do worse in Stat 2 and 7 this year? So again, you'd usually get more information, but just going off of the null and alternative hypothesis, it'll be mu is less than 72.3. Okay, the reason for that is because the last line you can see, it asks, did students do worse, right? So once you see that, did students do worse than Stat 2 and 7, then you know that the alternative hypothesis is going to be a less than sign, right? Basically, the alternative hypothesis is dependent on what the question's asking. If the question said, did students do better this year, then it would be a greater sign, right? And then as well, we're using the mu sign because it's asking for the mean, right? Instead of last question was using proportion, so it's a p. This time it's using mu, so we use mu. In other questions as well, you'll be using maybe x bar if you're only looking at sample means, So generally, depending on the question, you can change it, but at least for this one, it's mu. And then of course, null hypothesis is going to be greater than or equal to 72.3, right? Make sense? Good. All right. So quickly, just the type of hypotheses as well. So you'll have your left or slash lower tailed. So you can see just the examples there of the null and alternative hypothesis. You have your right slash upper tailed, so it's basically just the opposite. Then you have your two tailed, which basically uses equal signs rather than greater than or less than, right? So as you can see here, basically to know if it's left-tailed, right, or two-tailed, you essentially look at your alternative hypothesis, right? At least I do. I mean, I'm not sure if that's what the profs do. I mean, but that's just what I do, right? So as you can see here for the left-tailed, you can see it's a less than sign. Right is the greater than symbol, right? And then obviously two-tailed, it's equals. So for two-tailed, it'll always be an equal sign or non-equal sign. You don't have to worry about less than or greater than, doesn't matter, right? But just a quick question. So for this example at the bottom, what would you say is the type of hypothesis? Is it a left-tailed, right-tailed? Is it a two-tailed, maybe? Well, it is in fact a right-tailed test. And the reason for that is because even though the sign shows less than, right? The signs are going off of the mu, or whatever symbol you're using, right? So technically the sign is greater than for the mu, right? So generally, obviously questions, I doubt they'll do this to you, but it's just keep in mind that in case for whatever reason they swap the symbols to the other side, just be wary of that, alright? Because the type of hypotheses really does matter when you're solving equations. You will occasionally get completely wrong answers, depending if you get the left or right or two-tailed part wrong, right? But anyways, this should be easy. You should know this. And then also, okay, how do you even choose null or alternative hypothesis, right? Which one do you choose? So obviously you choose based off the p-value. The definition of p-value is the probability of finding stronger evidence against the null hypothesis, assuming H null is true, all right? And so obviously, I mean, you get p-values with your tests, and essentially obviously tells you which side you should choose, the null or alternative hypothesis. Oh. And another key part about the p-value is you use the alpha, or the significance level, to determine that. So essentially what it comes down to is if your p-value is less than the alpha, or significance level, you would obviously go with the alternative hypothesis, right? And if it's greater, you go with null, right? So there you go. Now, key thing to note is that the alpha is sort of, usually it's 0.05 or 5%, is generally what alpha is, but certain questions will change the alpha. And yeah, it is very important because let's say your p-value is 0.06, let's say. If your alpha is 7%, right, then your p-value will determine that that you should fail to reject the null hypothesis. But if your alpha is like 2%, then it's the opposite way, right? So, and that's another key thing as well. You should not choose the alternative hypothesis. What you should say is you reject the null hypothesis or you fail to reject the null hypothesis. I mean, I don't know why. I mean, that's what they like that, I guess, but I don't know. I feel like it's easier just to say choose the alternative hypothesis, but whatever. Now this brings us on to the type 1 and 2 errors, alright? So back to the p-value. Basically, type 1 error is the p-value, and it's essentially the probability of, or not the probability, but it's basically when you reject the null hypothesis when it's actually true, right? And so the p-value is basically the chances of doing this, right? And so that's why you want your p-value to be low, because if your p-value is low, right, that means you could choose the alternative hypothesis and be somewhat sure that according to your sample, there's a very, very low chance that you're going to be wrong. You know what I mean? Sorry, I'm not very good at describing this, but point is that's a type 1 error, right? Type 2 error is the opposite, right? So first of all, equals beta, and it's, yeah, again, the opposite. So it's failing to reject the null hypothesis when it is actually false, all right? So in this case, it would be if you, according to your sample, you conclude that uh, uh, basically you accept the null hypothesis, but the null hypothesis is false, and actually the alternative hypothesis is false, or the alternative hypothesis is true. Sorry. Um, in an actual test, you won't really know like the actual if you're right or wrong, because obviously you would need to either know mu or you need to either you know what I mean, right? So again, back to the example of this elementary school students, if they prefer to actually find out how many students actually prefer math over English, the only way to know if you actually committed a type 1 error or type 2 error is actually going out there and asking them, all right? And so I will say that some questions, though, that you will encounter will, in let's say like a part C or D or whatever, they will give you a fake mean or fake proportion, and it will ask you to, you know, calculate the type 1 error, type 2 error, blah, blah, blah. So keep that in mind, but realistically, you won't actually have to deal with this. And then you have power. So power is basically just the probability of being right when rejecting the null hypothesis. So you choose HA, and that's basically the probability of how correct you are. So it's basically just the opposite of type 2, and it's 1 minus beta. So if you want to get power, just first find beta, then you do 1 minus beta, and that's your power, right? Whew, okay, now on to the important stuff. So the first type of question you'll kind of encounter at the beginning is one where you have mu, standard deviation, and just an important part, it's the population standard deviation, so that symbol right there. You'll need n, so your sample size, obviously, x bar, so your sample mean, and obviously your a, your significance level. And again, just to keep in mind, if you don't get a significance level, I would just assume 0.05, so 5% a, but generally they'll be an a, right? And so you're going to want to use z-test for this, all right? And so and at the top right, you can basically see that you have your left tailed, right tailed, and two tailed. So that's why it's important to make sure you have the right type of hypothesis, because they use different formulas to get the answers you're looking for. Except for the z-statistic, and it doesn't matter which one, it's the same for all of them. So right here you can see the z-statistic, x bar minus mu divided by population standard deviation divided by square root of n, so your sample size, right? Simple. And then you can calculate your p-value here. It's simple, just p norm z-statistics, and then you have your other types right here. To get the x bar critical value, it's just q norm of your significance level. Then you add your population mean. Then you have your population standard deviation divided by square root of n. And then you have your other types here. And then if you are asked to get beta or power, which is somewhat rare, you do p norm population mean, x bar critical value, um, then you have your population standard deviation divided by square root n. So it's kind of, they're all pretty similar. I will say for all these equations, they have handwritten counterparts. So if you really wanted to, you could go and search up the actual handwritten calculations, and you could theoretically do these by hand and not through R. But I mean, like, I don't know. Good luck if you want. If you want to do that, I mean, respect, right? But I would not do that. The questions are way more difficult than just this. Okay, so now on to the second type of question. So as you can see, the second type of question is pretty much identical to the last one. The difference is you have S, or your sample standard deviation, all right? And so this is actually very important, because without the population standard deviation, it changes a lot of things. You can't use the z-test anymore, and instead you have to use a t-test, all right? So here to get the t-statistic, you just do sample mean minus population mean divided by sample standard deviation divided by square root of your sample size. And one unique thing with t-tests and a couple other tests later on is you'll be using df instead of just your sample size. And df is just your sample size minus 1. So, I mean, it should be pretty easy. And then here are your p-values. You just use the pt function of your t statistic, and then along with your df. And then obviously here are your other parts. So, yeah, this is a relatively simple type of question. But just, yeah, that's a big thing. So generally questions will specify whether it's a population standard deviation or a sample standard deviation. So this is very important, so don't mix the two up, all right? Now your third type of question is identical to the second. It's just this one uses data. So occasionally they might give you no data and just give you the sample standard deviation, blah, 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 right? But other times they might just give you the data and you'd have to find those things, like, sample standard deviation yourself, right? And so for this, you still use the t-tests. However, it'll be a bit different, right? So before you even use the t-test for data, you first got to check to see if it's normal or greater than or equal to 25, all right? If it isn't, then you should not use the t-test, all right? And so to test this, you first download the NorTest package, and then you just do 80.test of your data, all right? So this doesn't have to be named data, it can be whatever. Whatever your data is named, you just do that to the 80.test. And you'll get a p-value, and as long as the p-value is greater than alpha, then your data is considered normal, all right? And this is a pretty important thing because later on you'll also have to be doing this. But yeah, you can do that. You could also use like box plots or just a normal plot and do it by eye, but I mean this is just simple, right? It's easy. And if it is normal, then you can find the t-statistic and p-value by doing t.test of your data, population mean, and just, yeah, alternative equals less, alternative equals greater, or alternative equals t, right? Simple, boom. And lastly, your fourth type of question. So this question is kind of like the first question, except instead of using means, it uses proportions, right? So if you're asked a question that asks about like percentages and stuff like that, this is the question you'd be doing. So again, you're back to the z-test this time because they'll generally give you a proportion of, so a p-hat, right? And so here's a z-statistic. It's a bit different. You do your sample successes. So I should also note that, yeah, the questions are something like, I don't know, how many people, if it's a question about like voting, let's say, it'll give you the amount of participants. So let's say 100, and then it'll say how many people voted for a political candidate A, right? And it'll say maybe 20. So that's what the x is. X is basically the how many successes within the sample size, all right? So obviously x will always be smaller than n, all right? Just to make sure of that. So anyways, so the z-statistics, you go sample successes divided by sample size minus population proportion. All right, you divide all that by the square root of your population proportion times 1 minus your population proportion, and then that divided by n, all right? And then once you got that, you get the picture. You just, for the p-value, you do the p-norm z-statistic. For the p-hat critical value, you do q-norm, your significance level, population proportion, and you do square root of your population proportion again, times 1 minus population proportion divided by n, right? Oof. And then for beta, again, it's your p-norm of your population proportion, then your p-hat critical value, and then the square root of your population proportion times 1 minus your population proportion divided by n, right? So these questions are generally a bit longer, but as long as you generally follow these formulas, then you'll be fine, right? Okay, cool. So now that we're done that, just as a quick conclusion, for those formulas, generally, like, you should be able to solve almost every question. There will be some questions that have to that'll make you think outside of the box. They might be weirded wordly, or they might say, I don't know, find your alpha or find this, find that. But generally, though, if you follow those formulas and you maybe alter them a bit to fit the question, you should be able to solve everything. All right. So I hope that was, I don't know, helpful, I guess. I'll start making a part two. I'll just say right now though that it won't be as in depth. Like, I don't know, this took way longer than I thought it would. But yeah. Anyways, I'll see you next video.